everyone. Welcome to Introduction to Docker. My name is Misha, and I'll be presenting this workshop today. So before we start off, I want to give some insight as to how I'm going to run this workshop. So a lot of it is going to be switching back and forth between the slides and giving examples on actual containers, like using Dockerfile. So hopefully you can follow along. If it's a bit too fast, there's always going to be directions notes. I posted them in the Discord, so even if you miss something, hopefully you can come back to it later. So first, I'm going to talk a bit about how Docker has caused a shift in the industry. So for a long time, people made applications in a monolithic fashion. So these are often very easy and quick to make. The idea behind it is the whole application is a big one process monolith. So if we look here, the users would interact with a single process as the business logic and all the features interacting with possibly a single database, maybe multiple, but the idea is everything is grouped into one big clump. So the problems here it's often hard to maintain. So people might be working on different features and they might collide. So one person rarely changes something in feature A, causing breaking changes in feature B. In addition, it's a bit harder to expand because changes. So as I mentioned with the breaking features, if you want to change something and fix it later, it might propagate into many of the different parts of the process. Additionally, some monolithic applications are usually a bit longer to deploy in terms of startup time. So actually getting it, deploying and developing might take a bit longer in that sense. That actually seeing the changes in the application might take a bit longer. So over the past decade or so, microservices have become much more popular. So what a microservice is, or microservice architecture, basically splits the code into smaller code bases and different services, and in particular into multiple processes. So unlike the monolithic, here microservice A, B, C, and D can all be a different process. And the user might still interacting through a single process, like an API gateway, like an REST API, but in general, the idea is to make everything more decoupled and spread apart. So the benefits here, again, compared to the microservices, is you don't need as many launching or changing a single service. It doesn't often affect the other services. And having just launching one service or making one change, you don't need to actually update that service. So in general, that's some of the big benefits of this microservice architecture. Some drawbacks, though, is compared to, going back to monolithic, those are very much easier to reason about, but here they might cause complex diagrams and seeing all the relationships with how all the microservices communicate. So a lot of the ideas behind Docker stem from virtualization. So the idea behind virtualization is to abstract away the hardware. So like memory and CPU usage, we don't want the actual processes to care about these sorts of ideas. All they need to know is I want this memory. It doesn't need to know how to interact. So this abstraction of hardware is a big concept in virtualization. So the way this is done is through a software layer. And this will manage all the resources for all the processes to handle how much each process gets. And the goal is to actually split a single bare metal computer, like an actual physical device, into multiple virtual computers. traditional approach has been virtual machines. So here, the main component that sits on top of the hardware is a hypervisor. This is the software that I mentioned before that actually manages the resources. So there are two kinds. So above the hypervisor, it manages the resources, again, memory, CPU usage, network usage for virtual machines, VM1, VM2, VM3, so on. So virtual machines, there is also an optional operating system layer between hardware and hypervisor. So this distinguishes type 1, which don't have operating system, and type 2, which do. So if you've ever used a virtual machine, like VMware workstation, or like on your personal computer, you probably use the type 2, which has your main operating system installed. Docker containers, on the other hand, have uses runs a Linux system. So all containers will be running a Linux system. So on top of hardware, the kernel is what manages the actual resources. So this is just a normal Linux kernel, which all the Linux operating systems will use. And on top of that, we have the host operating system. So this is what actually helps you coordinate the resources. So the kernel kind of allocates all of handles allocation, and the host manages how it's distributed. And finally, the Docker daemon, or that's the actual processes of it. The host is what it's running. And from there, that's what the containers C1, C2, C3, you can have those be managed by Docker. So something to keep in mind. So something interesting that these two technologies actually work well together. So this Docker with the Docker containers, the host operating system has to be a Linux distribution. So usually, if you're running on Docker on Windows or on Mac, this actually the kernel host operating system and Docker actually lives in the VM. So that technology really helped push this one forward. So what specifically is Docker? Docker is a tool that helps you work and manage the different containers. So you can run containers or interact with them. So there are two main components. So there's the Docker daemon that I managed from the diagram before. So that's the process that manages the resources. And clients, so that's what we're actually going to be running to help interact with it. Now, the part that we've been waiting for, getting started with Docker. So let's actually get into it. But before that, if you haven't installed Docker yet and want to follow along, please do so. Here's the link to it. So while people are doing that, I'll explain kind of what I'm hoping to do during this workshop. So first, we're going to be running a few containers. I'll show some commands as to what you can do with containers and the different resources Docker has. And then we're going to be making a Dockerfile. So those give a way to build a template for containers. I'll talk about that shortly. So the idea is, the goal is to, again, do some examples and then build your own template. So first, let's get to launching our first container. So to launch a container, we need an image. This is the template I've been talking about. So this contains the files that will be used inside the container. And this is a template. We don't really need it. We can use it for multiple different containers, which, as I mentioned, these are the processes that actually run. So the difference between images, they describe what your container is going to look like, and containers are actual processes that run. So let's get to doing that. So this is for a few slides what I'm going to be before I'm going to show. So we're going to run our first container. So let's boot up Windows your code, make an internal, let's run Docker run, and a classic first container to run hello world. So something you'll probably see when you run yours is this here at the top. Let me make this bigger. So unable to find image hello world with locally. So what's happening here is you tell Docker you want to run this image called hello world, a container made based off that image. And it's trying to look for that in your local images. But we haven't done nothing with Docker yet. All of our images are blank, or we don't have any at the moment. So what I'm going to try to do is look online for an image called hello world. Luckily, we have one in Dockerfile, so hub.docker.com, and you can download the image here, and then now we ran it. So hello Docker, and all of the whatever the image does. So now what we do, we'll see what images we have. So Docker images. So we see that we have the hello world image downloaded locally. Yes? You can if you want. You can feel free to just watch, and hopefully you can take something in, and if you need to, you can always look back. But feel free again to follow along. But yes, so Docker run that launches the container. Actually, yeah, it runs it, and then now we see we have our new image. So if we now do Docker run again, you can see we didn't get the unable to find the image locally because we now have it. So it ran it normally. Here we go. Now, if we look back, we have instead of just running an image to get an image, we can also do pull. So let's pull the Python image. So pull does the actual downloading the file. So let's Docker pull Python, for example. So that might take a while. So this default Python image is kind of big. But while that's doing that, let me talk through the other two. So PS gives you like a health status of your containers. So it gives you like some information about what the containers, your current containers on the system. So you can just run Docker PS to just see your active containers, or you can add -a, like an example there, to look at all of the containers. Now, Docker logs, we saw for our hello world that it printed something out. That will be part of the logs of the container. And we'll take a look at it in a moment. So we just pull the Python image. So if we take a look at our images again, we can see we have Python now. Now, yes, now we can look at the other two commands. So Docker PS. So interestingly, we don't have any containers up at the moment, so none are active. But we did make two containers, so we ran hello world twice. So if we look at -a, we can see the exit status there for the containers. So under status, we have that exit. So this is why we need the -a to see all the containers. And then now we can you might see two different ways to identify a container. There's an ID here, which is a hash number, a hexadecimal number, and then where is it? Oh, at the end. So name. So the name of the container. Now let's try checking the logs of the two containers. We can use both the name or the ID. So Docker logs, and the ID is nice 1998, etc. So if we look here, this is just hello world. So this is the message we saw before. Now you can also type in the specific name, Docker logs, cool, the LAN, for example, and then it found the logs again. So let's move on. So now let's talk about cleaning up a bit of all the images in containers we made. So first we can remove an image. So we don't really care about the hello world image at this point. When we ran it once, we saw that it worked. Now we can remove it. So RMI, hello world. So something you might get here though is this error response. So we ran two containers with using the hello world image. And what Docker wants is that there are no actual references to this image anymore. So, but if we do PSA, yeah, these ones use the hello world. So this goes back to this second command of Docker RM. That removes actual containers. So let's Docker RM. We can again do the same idea. We can use the ID or we can use the name, and those are removed. So if we run Docker PS again, no more. Then deleting the image works just fine. So these two, Docker remove image and Docker remove, they remove the images and containers respectively. So kind of like in the same fashion as images, Docker remove can't remove an image if a container, or it can't remove a container if it's running. So something you might need to do is to stop the container. So there's a Docker stop, or if necessary, you can Docker kill the container. So moving on. So one thing with images is you can version them using an image tag. So what the format here is the image name : tag. So what this helps you do is give you options for what kind of image you want. So this might, for example, with the Python image, we want maybe the latest one is Python 3.10, but we want 3.7 or a specific node version for node container. And then another reason to have tags could be for different architectures. So I'm on a Mac, I'm running on an ARM architecture, and then that might be incompatible with AMD x86. So tags may be useful in those cases to be able to run different kinds of architectures. And then what we can do is make a new image using Docker tag. For example, we have the Python image, so we can make a new image that's the same template, but which with a different name. So if we go back here, first let's actually pull a different kind of tag for the Python image. So I mentioned before that Docker as a Python image is pretty big. So I'll pull a smaller one. So that's Python Alpine. So this runs on Alpine Linux. So now if we do Docker images and compare them, so we have two images named Python with different tags. So we see the tags here and here. And if we look on the side, the Alpine version is 47 megabytes compared to normal that runs on Ubuntu 800 megabytes. So that's quite a big difference in this case. So having a smaller image size might be useful for what you're doing if you need to deploy. Unless you really need a bunch of, I think Alpine is a good choice. So now we can Docker tag. Let's just be easier so we don't have to type the whole Python outline. Just Docker tag Python outline as pi, for example. Now, if we look at the images again, we have a new image called pi. So the image ID is the same as the outline version of the Python image, just a different name for it. Cool. So these are like I showed you a few nice tooling commands. So let's actually make Docker run a bit more useful. So first, let's run Python run a container with our own command. So normally the images, they have a default command that you want that will execute if you just run it normally. So for example, let's run the Python container. So Docker run Python. So interestingly, it exited. So this is actually something I'll bring up in a second. Or let's actually look at that. So for Python or Docker, we can pass in the IT flags. So this is two flags there. You can give what I intuitively think of as an interactive version of the container. So we connect to the container interactively. So we can run with this IT flag, these IT flags. So Docker run IT Python. And so what the default command for Python is the Python command. And if you don't supply the command, that'll just open the shell. So this is just Python, so we can, for example, print hello Python, and then it works as the expected shell, a Python shell. So exit out of that, exit out of the container. So we all can also run our own custom commands. So here, for example, Docker run Python bash. So bash is the shell in Ubuntu or the default shell. So we can run that. Again, we're gonna need the IP flag to actually keep it alive. And bash. So what this does, it opens a shell inside the Docker container. So this is just like what you expect from an Ubuntu operating system. So you see all of your folders, ls. So the binary, we see all of your normal commands here. Now, this might be useful if you want, for example, run a special version, like a special command. Bash by itself is kind of not the most useful to run, but let's keep it alive for now. So what we can also do inside the container is we can make some changes. So we can, for example, make a new file or edit a different custom file or delete some stuff. Basically, somehow modify the container. We can also, this includes the environment variables and the like. So we can run inside a container this echo print hello world, hello blah. So let's quickly do that. Echo print hello world, and then we put that in hello.py. Now this, we can just run this just to make sure it works. And as expected, it prints hello world. Now when we exit out of the container, we might want to keep this file around for future runs. So let's exit out, and we can see -a. So we are in the Python image. So we saw the command here. This was the batch one we did. So this is one that I'm just exited. So we want to save the changes to what we did. So we made a new file. We want to keep that file for, again, future runs. So we do that here, as I mentioned, I wrote down Docker commit. So we specify the container and then the image and an optional tag. And this will create an image. So the one we did was, let me copy that, Docker commit. And then for the hello object. And then we can run that now. Docker run. Hello, hi. And let's give it a special command, Python. And then that runs our new file. So we ran in the image that we created, we saved changes, and now we can just have the changes run on it, or have those changes appear automatically as part of when we run the image or the container in this case. So moving a bit, moving on. So normally Docker doesn't have access to host OS files. So I didn't expand on this part, but the benefit of virtualization is you can isolate different processes or different machines. So in this case, containers or VMs can be isolated, but here the containers don't normally have access to the host OS files. But we can share some of them using a bind mouse. There are actually two, like a traditional way of doing a bind mouse, and this will be a more modern way. I'll show you quickly the more traditional way after, but let's start with this one. So bind mouse can be specified using the mount option. So it's this not the 30th format, but you give it a source and file or a directory as the source, and then a file or a directory as the target. So let's try that. For example, let's in here make a new file called a host.file. And here print hello from host. Now we save this in the same directory. So it's here, and we want to share this host.file with a Python container. So how we do that is, again, using the mount option, mount type source equals, and this is the important part. The path to the file has to be the absolute path. The easiest way to do that in this case is just use pwd, getting the working directory, so printing the working directory, and then using just moving on that. So hello target equals, let's do hello / main.hi. Oh, I can specify the image. So I'll see Python. Let's run the bash command in this case. So, let's see. Type equals line. I'll take a look at it, but the easier way to do so is, like I personally use this more traditional method, is using -v. So using -v, and then you specify your source as the first part here, and then you just put a colon, and then you put your target. So in this case, it will look like this. I personally like this a lot more, but Docker's been moving away from this format, but this should work. So invalid volume, here, I got it. Here, oh, and IT. Cool. So the idea here using this format for the bind is to you can map one file from the host OS to the container. So we can look in the hello and see that main file. So we saw this mapping here. We mapped the file to hello/main.py, and there it is. So if we take a look at what that actually contains, so main.py, that is, let's see. Oh, I'm sorry. I was doing the wrong way. So it's not called hello.py, it's called host.py. Let's change that a little bit. There it is. So ls hello, indeed, and hello/main. Cool. So we see the hello from host. We don't have a new line character to enter it out, but there it is. So what we can do, or we see that the file from the host OS map to the container. So the thing is here, this is a map, a direct mapping. If we change something inside a container, it will affect the file outside of the container on the host OS. So let's, for example, add a new line first, echo, and then hello/main.py, and let's add a new line for the Python file. So let's do another print statement. So hello from container, and then append that to hello main.py. Now, if we look here in the editor, the file change is updated because we did so inside of the container. Now, this was now let's take a look at quickly detaching from a container. This is a very useful to have multiple containers running. You don't have to manage them all at the same time. You don't have to have terminal open for each one. The point here is that you can have them run in the background. So the easiest way to do that is to use a shortcut Control P and Control Q. So you press Control P and Control Q. I've had issues with Visual Studio Code, but it works great in the terminal. So for example, Docker, so I'll connect to, or let's run the container. Let's get one of the simple ones first. Here, for example, and then Control P, Control Q. You didn't really, it didn't really show for you guys, but again, those two key commands, key shortcuts. Now if we do Docker.js, we can see we have two containers running. So this was the one we just had that we detached from, and then the other one is the one that's actually running at the moment. So it's currently in a detached state, so it's running in the background. Another option for running detached is to pass in the -d flag. So kind of like with most other flags, we can just put it in. So -d, and again, we will have this E for a A3 container here running. So these are two relatively simple ways to get containers running in the background. Now, I'm kind of tried doing this previously, but we can also attach it back to a container. So this is just the Docker attach. So I'll go in the opposite way from detaching. And also the E4. And we're back in. And the fun part, this is what I like, I find very useful. It's exposing a port. So what this means is that you can expose a network port for Docker to use. So similar to files, Docker normally doesn't actually have access to the network ports on your computer. What you can do is, again, similar to files, sharing them using by exposing them. It works using the -g, and then you specify the host port. So the network port on the host that will be used, and then what on the container it will map to. So they'll have to actually be the same one. For example, we can bind on the host 1234 to port 80, which is like the HTTP normal HTTP port. Now I have made an image called Genmax6, so we can try downloading that and then see how that works. So Docker pull the Genmax6. So something with this one, Biden does default image here. It runs, it's on, as I mentioned, the ARM architecture. So you might want to, I have made 2 different tags, but you can do Genmax6 AMD if you're running on an AMD system. So the ARM one probably won't work for you, but the AMD one should. So I mentioned a while back that we can use tag. So we did that to make calling Python outline order. So let's quickly do that here as well. So our Genmax6 image, let's just call it JH6. And now, again, it's kind of like an alias in this case, so it will be easy to call. So looking back here, what this image does, it hosts a REST API on port 8000. And so if we forward 8000, we don't need to do it in 8000 on our own system, but for simplicity, let's just not the same one. And then let's try talking to it. So Docker run, let's detach it, MP 8000, and then JH6, for example. Let's see now. Let's try curl. So it will be a REST API, the local host 8000, and then this is where you'll have to read on the documents on the notes ahead. So this has the jam and collector here. So it shows you all the jams available. Or the jam/strawberry. And it'll give you the data for the strawberry jam that we have with the server. So this is an example of using giving access to network ports to the Docker containers. It's useful, especially if you're gonna have people or outside connections trying to talk to your application you have, again, just kind of like a REST server, for example. This is a great way to do it. So if we look here, let's stop that for now. GD. So let's try to do using a different port. We're going to have to use a slightly different code and just change the port number there. but let's do 8002. 8002. Then it works the same way, even though in the container it's still 8,000. So there's also I provided an alt tag. So image name alt and AMP_alt, and those map to those hosts on port 20,000 instead. So you can play around with that. But I'll move on to the next topic, which pretty exciting. It's writing a Dockerfile. So up until now, what we've been doing, we've been using existing images and then maybe slightly modifying them. But overall, we haven't done there hasn't been a great way for modifying images and making our own. So a Dockerfile is basically a way, it specifies a way to build an image, and we can build it using Docker build, which I'll show on the next slide. And the goal here is to for the general format is basically here's where we start off. We're going to start off with, for example, an outline image or a Ubuntu, or for example, we can even start off with the Python image. So figure out where we want the starting point to be, and then run some command instructions on it. So for example, we might want to copy some files, or run some commands, set environment variables, etc. And then finally, we can specify a default command to execute when you want a container. So we've seen, for example, the Python image. We have the Python command is the default one that gets executed. We saw that it opens the shell. So what actually goes into a Dockerfile? So I'm going to talk about the instructions. Some of them overlap, but at the bottom, for example, we have the Docker build, and we can tag it with a specific name. So let's start building our Dockerfile. So in the repository I linked, I mentioned that at the start, you'll see have this REST server folder. This is the same one as that's running on the X6 image. So we want to build an image using these files. So let's make a new file called the Dockerfile. Oh, not folder, file. So from here, we're going to do basically the general format that I talked about. And that starts with the from keyword. So we start off with the first one. So from, and let's use one of the Python images. So our server is going to be on Python. Let's use the outline version, for example. So Python outline. We don't really care about any of the Apache stuff. So let's see. Let's Docker build T my app, for example. Let's just call it that. Oh, I forgot to dot. Cool. So it builds the image. Now we look at the images. Now we see my app there. So yeah, the build was successful. Now if we just run my app, this is just exactly the same thing as the Python image. We didn't do any changes, so nothing really, nothing's different. So let's look at the next keyword, the copy and add. So copy just copies files from your computer into the image. So whenever you launch an image, those files, like a copy of those files, will be part of the image. Add this is basically the same functionality. It is just a small superset. So what you can also do is, for example, decompress archives like zips and tarballs, or you can even get data from a URL, so over HTTP or something similar. So in general, if you just need some files, just use copy. Don't overcomplicate it with add. So we want to copy our REST server files over to, let's say, /app. So copy REST server, and then in the container, we'll access it in /app. Now let's build this again. Docker run, and then we'll see. Oh, let's do the bash command instead. Let's see. Oh, right. Alpine does actually have the bash, so we've been using the Ubuntu version. It has an SH instead. So we log into the container, so we see LN, we look at what folders we have, and in /app, this is all the files in the REST server. So you can see like here. So it looks like the copying works well. Now let's look at the next ones. So run. So let's try actually running. So I did it prematurely. Let's try running our app. So let's go to app and Python 3 main. So we see here we don't have a module called Flask. So the app works on the Flask module. You don't have it. But we want to be able to install it. So here we can just go in, install specifically Flask RESTful. That'll install it Flask as well. So that's one way to do it. But we want to always have it available whenever we launch a container. We don't want to actually run Flask. So this is where the run instruction here comes in. So this just runs a command. So we can do if install during when building the container, or building the image. So in this file, run, and then pip install, and so there are a few options of how we can install this. We can just say Flask RESTful at this point. That's the only one we actually need to specify, but to be more, have it be more safe to future changes, for example, we might want to use the requirements TXT. So this is just here. So let's use that method of installing the dependencies. So requirements TXT. Cool. Now if we build again, then run this out again. CD app name. It works great. So it launches, it does all the stuff. And then this is basically where we, yeah, it's working. So, but there are a few things. First of all, it's not launching automatically. We want to have the container automatically launch the server. Right now, it's still stuck in that normal Python, just running Python commands. We're going to quickly see, we're going to look at how to change that. But before that, let's quickly take a look at two other instructions. So end. I'm not going to go too deep into this one. This just has an environment variable. So we can say end my app equals /app /main.py, for example. So this will just add an environment variable. Again, it's not too difficult. So if you know about it, already know about environment variables, it's Yeah, it's what you expect, but otherwise you can, for example, for us, we have like if I set the reference variable here, my app equals name I, and I can dereference it in using the dollar sign. So this is you can do the same thing inside a container. The other instruction is work directory, so work here. This will change which directory you run your command from. So by default, it's from root. But here, if we, for example, change work directory to /app, that's where our servers currently residing. Then we can just reference all of them from there. So for example, we reference /app here, but if we move this up, then we can just sort of simplify this a bit. We don't have to use like your reference to path there. The work directory changes where it's working from. Now, we can build that again. I'm not going to run the image, but yeah, that works fine. And then finally is the more exciting part. So this is the third part in the template. So the default command to execute when launching a container. This is this last part. So CMD and entry point, they both specify the command that you are going to run. They're slightly different. So CMD gives a default command, which you can override. For example, the Python image that we've used within brand batch, that would be using the CMD. Entry point, on the other hand, gives you the specific executable that's going to run, and you can't change the default. So if we would run, give extra arguments after the container name, that would give the arguments to the actual execution that you ran. So if we entry point, for example, and then we do Python 30 main.py. So this will run the main.py file under using the Python 3. So yeah, we can build that. And so for example, if we run this again, so we go back here, and if we type in sh, this will consider it as if we ran inside the container Python 3 main.py sh. So it doesn't override the command that was given before by Dockerfile. Instead, it adds onto it. So CMD is, again, if you give command after, it will just cancel out and override. You will specify specifically what you want to do. Here it's a bit, it's easier to be more rigid. So whichever one you want, I think it's very much situational. Yeah, very situational. Here, I'll just use CMD just so we can use shell eventually. So let's build that. And Docker run. So let's go back here. We know the server runs at port 8000. So let's run this one. So my app. So this is running now. We see again in the logs here port 8000. This is inside a container. So if we curl down here, for example, this will, oh, not 800, 8000. So it does exactly what we had the other image doing. It runs, it does, and gives back the rest API. All right, Control C. So that's that's what resolve the Dockerfile that I'm going to talk about today. Next, I showed a few basic commands. So a few next steps for learning Docker. So just to wrap up, I'm going to talk about a few things you can look at next. So first of all, other Docker features. So I didn't talk about all of the Dockerfile instructions. You can take a look at some other ones. No, they aren't too complicated, but I gave you the main ones to get you working with the Dockerfiles. Some other Docker commands. So there's, for example, Docker exec, or we didn't look at stop or kill too much, or you can also look at Docker volumes and networks. So there's a lot of stuff in Docker itself, features that you can start taking a look at. And then, so next is the Docker Compose. So this is an orchestration tool for Docker. It helps you manage containers and helps you make have them collaborate or communicate a bit easier. So you don't have to worry about like manually running your own containers or making some sort of script to launch everything that you want. Docker Composes very basic orchestration tool. And finally, the interesting standard at the moment is Kubernetes. This is a more robust orchestration tool, so it will be kind of set up after Docker Compose. It's very powerful, and you can do good scaling with Kubernetes. So hopefully this will give you some ideas as to what you could look at next. But before we wrap up, I want to give you a few takeaways. So first of all, the first thing is I'm not going to expect you to remember everything I talked about here. I'm not expecting you to be an expert on Docker at this point. The goal is to give you information, some ideas as to what's out there. And then you can look up specific syntax or specific commands or specific Dockerfile instructions. It doesn't matter what the specifics are. The main thing that is important is that you know about something that exists. And then another thing is very much to practice. So to really cement your knowledge, you need to apply, like I find it very useful to apply these commands and tools and then be like personalized using all of these, all the Docker and all of the different commands. So it helps me, personally helps me remember, and practice will really cement your knowledge of it. And finally, yeah, it's great to be curious about like all the different features and like see what Docker can offer and all the different tools. I talked about Docker Compose and Kubernetes, like being interested and looking forward to looking into some of these tools is very important. But you don't have to. You should realize you might not understand it right away. Like learning is really hard, and you have to be patient. That you might not know everything right off the bat. So hopefully, with I gave you some of these points from